screencast I will show you how to conduct non-parametric tests. When working with real-life data, sometimes the parametric assumptions are not established when screening your data for outliers in normal distribution. In addition, some data by definition is nominal or ordinal, therefore you cannot use parametric tests. If your data does not have normal distribution and has outliers present, you will have to conduct non-parametric tests. In the other screencast I have shown examples of parametric tests, as the data was interval or ratio and so met parametric assumptions. Parametric tests allow you to analyse the data that is nominal or ordinal or data that is not normally distributed. I will now show you how to conduct a non-parametric t-test. Before conducting a t-test you will need to screen your data. Please see the screencast titled Screening Your Data for instructions. Once you have screened the data you can conduct statistical tests. A Mann-Whitney U-test is the non-parametric equivalent of a t-test. An example of a research question that would require a non-parametric t-test is there a difference between males and females on perceptions of health? As the dependent variable, perceptions of health, is ordinal data, you cannot run a parametric test. Instead, you would run a Mann-Whitney U-test. To run a Mann-Whitney U-test, go to Analyze, Non-parametric Tests, Legacy Dialogues, to Independent Samples. In the pop-up box, select your dependent variable, in this case health, and move it into the test variable list box. Then select your independent variable, in this case sex, and move it into the grouping variable box. Then click to find groups. You now need to label group 1 as 1 and group 2 as 2. Then click continue, check Mann-Whitney U is ticked, and then click OK to run the test. An output window will now include the results of your Mann-Whitney U test. The table you are interested in is titled Test Statistics. You are interested in the figures for Mann-Whitney U and a SIMP SIG. You will need to make a note of these figures for when you report the results of your test. Remember, if a SIMP SIG is 0.05 or below, then the result is significant. Remember, if SIG is 0.05 or below, then the result is significant. If not, then it is non-significant. When providing the details of the test conducted, I would write, a Mann-Whitney U test was conducted to examine the difference in sex, brackets males and females, on perceived health. When concluding the results of the test, I would write, there is a non-significant difference between males and females on their perceived health. This is when you would use the figures you noted down in the t-test table as evidence for your conclusion. Using the table, you would report the results of a Mann-Whitney U test as U equals 0.294.50, P equals 0.091. You would generally include these statistics at the end of your conclusion in brackets. You would report details of the test and the conclusions drawn from the results along with the statistical evidence in the results section of your dissertation. I will now show you how to conduct a non-parametric correlation. Before conducting a correlation, you need to screen your data. Please see the screencast titled Screening Your Data for instructions. Once you have screened the data, you can conduct statistical tests. An example of a research question that would require a correlation for analysis would be, is there a relationship between standard of sport and perceptions of health? As both of the variables provide ordinal data, you would not be able to run a Pearson's correlation. However, a Spearman's correlation would be appropriate and would provide similar output, just in a non-parametric manner. Using the two variables, standard and health, in my dataset, I can examine if a relationship exists. To run a Spearman's correlation, go to Analyze, Correlate, Bivariate. In the pop-up box, move your first variable, in this case standard, into the variable box, and your second variable, in this case health, also into the variable box. Pearson is the default, so uncheck that and click Spearman. Then click OK to run your test. An output window will now include the results of your correlation. We are interested in the figures for Spearman's row and SIG two-tailed. You'll need to make a note of these figures for when you report the results of your test. Remember, if the SIG two-tailed figure is 0.05 or below, then the result is significant. If not, then it is non-significant. For correlations, you also need to report the size of the relationship, that is, the size of the correlation output. 0.8 is generally known to be a large correlation, 0.5 is a medium correlation, and 0.2 is small. When providing the details of the test conducted, I would write a Spearman's correlation examining the relationship between standard of sport and perceived health. When concluding the results of the test, I would write there was a non-significant small positive correlation between standard of sport played and perceived health. The correlation is classified as small as it was 0.1 and positive as the correlation statistic showed no minus. This is when you would use the figures you noted down in the correlation table as evidence for your conclusion. Using the table, you would report the results of a correlation as rho equals minus 0.176, p equals 0.164. Generally, you would include the statistics at the end of your conclusion in brackets. You would report details of the test and the conclusions drawn from the results along with the statistical evidence in the results section of your dissertation. It is good practice to visually display data. When running correlations, scatter plots are the accepted way of presenting data. To run a scatter plot, go to Graphs, Legacy Dialogues, Scatter Plot, click Simple Scatter and define. Select the first variable, standard, and put it in the y-axis box. Then click your second variable, in this case health, and put it in the x-axis box. Then click OK. Your scatter plot is then produced. Scatter plots are a good way to show the direction of your correlation depending on whether there is a relationship or not. As you can see, in this case there isn't. They can be used to support your conclusion and can be either reported in your results section or in your appendix of your dissertation. But please remember when writing up your results that correlations only tell you if there is a relationship between variables. They do not suggest the degree to which one variable causes the other.